All right, academic chemistry, we are going to work on interpreting chemical equations. To start with, we want to look at each individual object and what state it's in. Is it solid, liquid, gas, or aqueous? And we'll also need to focus on writing properly everything that's reacting. So to start with, let's look at this guy right here. Aluminum, and it has a little s, which means solid. So we would call that solid aluminum. And after it is a plus sign. That plus sign stands for reacting. So solid aluminum reacts with and now I'm looking at O2 and a G here. Oxygen we know is part of Brinkelhoff. It's a diatomic molecule. So we just call it oxygen, and whenever we say that, we know oxygen is found by itself in a pair, and it's gas. So we can say solid aluminum reacts with oxygen gas. So we'll write that out, oxygen gas. And then after that, we have an arrow. An arrow means yields or to form. So we could say solid aluminum reacts with oxygen gas to form. And now we've taken care of everything on the reactant side. Now we just got to look at the product side. The product side is Al2O3. That is an ionic compound. So since it's a metal and a nonmetal, we'll use the ionic naming rules for that. So we will call it aluminum oxide. And since it's an S, it's solid. So the oxygen gas will form solid aluminum oxide. All right, now that's a simple way to interpret the chemical equation. Now we could go a step further by balancing the equation, and then from there we could include moles. We won't get into writing that for interpreting the chemical equation, like 1 mole of solid aluminum reacts with 2 moles of oxygen gas to form, 3 moles, whatever it may end up being. But we'll just stick with this simple one. But let's make sure we can balance it as well. All right, so to balance it, let's take a look at each side of the equation. On the left side, there's 1 aluminum. On the right side, there's 2 aluminums. So if I want to balance those guys out, I could put a 2 over here. But you'll notice that if I do that, even though I'll have 2 aluminums on both sides, my oxygen over here is 3 and my oxygen over here is 2. Unfortunately, those guys aren't going to work out being balanced, so I'm going to have to change the aluminum over here. So that actually doesn't work out too well for me, so let me erase that. Let's try that again. Since there's 3 oxygens over here and 2 oxygens over here, the same number they can both be, because they're one's even and one's odd, the same number they can be is 6. So if I multiply this by 2 and this by 3, I end up with 6 oxygen over here and 6 oxygen over here. But because of that 2, I also made 4 aluminum over here. So therefore, I have to put a 4 over here to give it 4 aluminum. Now, because of that, I'm nice and balanced with a 4:3:2 ratio. And as I was saying earlier, you could turn this interpreting equation into even more information. You could now say 4 moles of solid aluminum react with 3 moles of oxygen gas to form 2 moles of solid aluminum oxide. Again, though, we don't have to keep the moles in there for this. We're just trying to get used to interpreting chemical equations. Let's look at problem number 2. In this case, to start with, we have solid silver, because Ag is silver and it's by itself. And solid silver, because of that plus sign, is going to react with, so we say solid silver reacts with, and what's the next compound? Well, it's a gas, but it's H2S. Hydrogen is going to act like an ionic compound or a metal here because it's going to be a positive cation and a negative anion. So you can call that hydrogen sulfide. So we can say solid silver reacts with hydrogen sulfide gas. We'll write that in there. And again, that G in parentheses stands for gas. Chemical reactions and the equations are like a recipe. When you need to know, hey, is it a gas, solid, liquid, etc.? How much of each thing do we need? So hydrogen sulfide gas are going to react, And then you have this arrow. The arrow means it reacts to form. So we'll write that in for interpreting our equation. To form. Two things now. It's going to form solid, and what is AgS? Well, Ag silver, that's a metal. Sulfur is a nonmetal, so it's ionic. So I'm going to name it as an ionic compound with just a cation and anion name. So that's going to be solid silver sulfide. And this plus sign on the right side of the arrow does not mean reacts with again like it does on the left side. It just means and, because two things are forming. So solid silver sulfide is forming and hydrogen gas. Now a lot of people ask, well, when you name this, why don't you call it like dihydrogen or something like that? Well, remember, hydrogen gas is part of Brinkelhoff, which is that silly saying or term to remember all the diatomic molecules that are found in nature. When alone, they're found paired up with themselves. So hydrogen is no exception to that. So we just call it hydrogen. And if anyone ever said that we're reacting with hydrogen or creating hydrogen, we would assume it would be H2 and in the gas form. But there you go. We have it. Solid silver reacts with hydrogen sulfide gas to form solid silver sulfide and hydrogen gas. A lot of alliteration there in that solid silver sulfide. I like that. All right, but let's just balance this one up to make sure we have it. And again, we could add, how many moles of each, but for the sake of just interpreting the chemical equation, I just want to make sure you know that when we start with the plus sign on the reactant side, that means react with, and when we end with a plus sign on the product side, that just means and. But let's balance this bad boy out. So looking at this equation, on both sides I see that there's, let's see, 2 silvers over here and 1 over here. So if I throw a 2 in here, I now have 2 silvers on both sides. So my silvers are at least balanced. I have 1 sulfur on each side, so I'm happy with that. And I have 2 hydrogens on each side. So I think this one is nice and balanced with the 2-1-1-1 ratio. And again, just to recap, that means that we could take this interpreted chemical equation and add in our moles now. We could say 2 moles of solid silver reacts with 1 mole of hydrogen sulfide gas to form 1 mole of silver sulfide, solid silver sulfide, and 1 mole of hydrogen gas. But in the end, hopefully you're better interpreting your chemical equations and know what they mean. Thanks so much for listening. Best of luck. Try the other ones out. And remember, naming is important. So figure out if it's ionic or covalent so that you name it properly. And also don't forget the phases. Is it solid, liquid, gas, or aqueous? Good luck to you.